Okay, Amin, Abdiaziz. So proportionally means that it's getting bigger like all together. So if we take a picture of someone and you put it on a Google Slides will automatically do this now when you make the picture bigger. If you make it taller, what happens to the picture? It should also get wider, right? If you shrink it down, if it gets narrower, it should also get shorter. Okay? We're not making these crazy pictures where the face is really stretched out or anything like that. Proportionally means it's getting in that proportion. So to do this, we use a scale factor. And the scale factor is the number we multiply from the pre-image to the image. The number we multiply from pre-image to image. All right, if that number is greater than 1. So if I take a number and I multiply it by a number bigger than 1, is it going to increase or decrease? So I multiply something by 3. Generally, is that going to increase or decrease? Increase, it gets bigger. So if it's greater than 1, our picture is going to get bigger. And if we're multiplying by a number less than 1, so like by a half or by a third, if I take half of something, is it getting bigger or smaller? Smaller, yeah. So that's kind of a good way for us to check our work today is if you notice your number is bigger than 1, it should be getting bigger. If your number is less than 1, it should be getting smaller. All right, you're going to get a glue in. You're going to want to glue it in either on the left or the right side because we do have some work to show. As you find your glue in, if you want to take out a ruler, you can. If you want to use a colored pencil, you could today. I'm not going to use one because I didn't have time period 1, so I don't know. If you really want to use one, you can, but... Lovely. All right, here we go. First one. So as we do this dilation, it's 2.5. If I think about that dilation 2.5, that would be 5 over 2 as a fraction. In not decimals. What do we call the thing? Alex. They're really a big fan of fractions. How would I know by looking at 5 over 2 if that's bigger than 1 or less than 1?
If the top number is bigger than the bottom.
Yeah, so 5 is bigger than 2, so it's going to be a bigger number. Good. Okay, so overall, is this picture going to get bigger or smaller of that quadrilateral? Are we dilating it greater or dilating it smaller?
Greater.
Greater. It's bigger than 1. So what we're going to do is we're going to write down our ordered pairs here. So we have B, C, D, and E. And we're going to write down those ordered pairs. All right, so for B, what's our first ordered pair? Yep, -1, 0. What do we have for C?
-1, 2.
Okay. D is +2, +2. And E? Good. +1, -2. Alright, so we're going to take each of these and we're going to multiply them by 2.5. Or if we're using that decimal, or sorry, fraction, we'd multiply by that fraction. So we're going to do that for each of these numbers to find our new ordered pairs. So if I do -1 times 2.5, what would that be? Okay, refocus. -1 times 2.5? Would just be -2.5. 1 times anything is itself, and then negative times a positive is a negative. What's 0 times 2.5? 0. Alright, this one there's a lot of repeats, which is nice. So -1 times 2.5. Good, -2.5. 2 times 2.5. If you need to use your calculator, that's fine. I would use your Desmos. So 2 times 2.5. Yep, that's 5. So 2.5 and 2.5 together make 5. So now again, we have repeats here. We already did 2. What was 2 times 2.5? 5. So we have 5, 5. 1 times 2.5? 2.5. And -2 times 2.5? -5. So all we did here is, if you need to write this to remind yourself, is we multiply each number, or all numbers, by the scale factor. And this time our scale factor was 2.5. Okay, that's really all we have to do. So it doesn't take too long. So most people on their ALEKS today found the number and they just kind of had a split screen with their scientific calculator. And they were just kind of finding those numbers, and then they plot 1 point at a time rather than doing all the points at once. So they'd find D is 2, 2. Then they would put that in their calculator, find out it's 5, 5, plot that point. So we're going to plot these points now. -2.5, 0. Now with negatives, you have to be really careful with those halves. That means we're going to go left 1, left 2, and left a half. So we shouldn't be in the same range as that B. We should be past the next one. There's our B prime. All right, C prime, we got -2.5, +5. So left 2 and a half, and then up 5. D prime, we got 5, 5, so right 5, up 5, it's on the very corner here. And then E prime, we have 2.5, -5, so right 2, go a half more to the right, and then down 5 will be all the way to the bottom. So this is the one that you might want to use that ruler for. Once we get those kind of longer lines, it gets a little harder to draw nice straight lines. So when we talk about proportionality, that's when we talk about similarity. And similar figures, remember, are kind of like each other. Are they exactly alike? Oh, and that's just their sizes are different. So when I look at this, which one is the shortest side to start with? C to B. Is C to B still the shortest side? And the bigger one? Yeah, when I take a family picture, I don't know if you guys know this about me, I'm pretty short. Okay? When I take a family picture with my family, I'm the shortest one. We take that picture, we put it in a little picture frame. We made that picture smaller, right? In real life, we don't print out like life-size pictures at my house. We print out smaller pictures. In the picture, even though it's smaller, I'm still the shortest person, right? Mm-hmm. I take that picture, I put it on my TV screen, I make it bigger, and I'm still The shortest person, yeah. So even though we're making it bigger and smaller, whatever the shortest is should still be the shortest here. Whatever our longest side is should still be the longest. Those like comparisons shouldn't change. All right, last one. Dilation of 0.25 about the origin. So this one, 0.25, anyone know what that is as a fraction? It's kind of one of our main fractions we use quite often. 1/4 or a quarter, good. So if it's a quarter or 0.25, is that going to make this picture smaller or bigger?
Smaller.
Smaller. We're going a quarter of the size. Now this part where it says about the origin, that's just where we've been doing things this chapter, is everything centered around the origin. And that's a good way for us to check. If we have things in each quadrant, they should stay in the similar quadrant. Okay? So we'll start by writing down our ordered pairs. So we have T, U, V, W. I like it to go in alphabetical order, so that's why I do that. All right, so for T, what is our ordered pair for T?
0, -2.
Good. 0, -2. It just drops down 2. What do we got for U?
-2.
Good. -2, +1. V?
1.
Good. 1, 2. And W?
3, 0.
3, 0. Okay, and we're just taking all of these numbers and we're going to multiply them by 0.25, or in our calculator we can multiply it by 1/4. Desmos calculator is really easy to multiply by fractions because you can just do 1/4. If you're using your phone calculator, you would do times 1 divided by 4. Use just the division sign for 1/4. 1 divided by 4. All right, what's 0 times a fourth? 0. I don't need to put that one in my calculator. So 0. All right, -2 times 0.25. We get -0.5. All right, we just did -2, so we don't need to do that again. That was -0.5. What would be 1 times 0.25?
0.
Yeah, 0.25, good. V prime, same idea. We have 1, so that would be 0.25. This time it's a +2. So what would be +2 times +2 times 0.25?
0.
Yeah, +0.5. And then W prime.
0.75.
How'd you know that? How'd you know that?
That's 3/4.
You're crazy. Yeah, 3, I suppose, because 3 times a quarter is 3/4. Yeah, that's smart. Look at you go. Outsmarting your teacher. 0.75. And then 0. That's too much thinking on a 2-hour delay. All right, so as we do this one, it's going to be really important with those decimals where to put them. On your ALEX, I think overall most of the ALEX problems, they automatically put them at whole numbers. But if they don't, there is there's a new tool on your ALEX homework today called like a location finder, and you can type in the -0.5, 0.25, and it'll plot it for you where that point is, okay? All right, so we have 0, -0.5, so 0. -0.5 means to go down a half. So this is what I was talking about with the origin. T started on our y-axis. Where did T prime end up? Still on the y-axis. Okay, U prime, we have -0.5, so left a half. And then it's only up 0.25, so not even halfway up. And try and make sure that looks not quite halfway. U started in this quadrant. What quadrant is this? 2. And U prime ended up in quadrant 2. still stays in the same quadrant. So when we're looking at something going about the origin, it should stay in the same quadrant that it started in. 1, 2, we have 0.25, so just over, not even half, but then up 0.5, so up a half. And then lastly, we have W prime, which is 0.75, so over 3/4, so over half, but not quite to 1, and then no movement. Woohoo! You guys did it. All right, we still have about 8 minutes until lunch. So we have plenty of time for you to get your Alex open and get started on it. It's only 6 problems.